Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from June 2018, and this is paper 2, which is a calculator paper. So we're on question 21, and this is a question about finding the density of a block of wood given these measurements: 13.2, 16.0, 21.7. And these are all rounded up measurements, and what we're trying to do is work out the degree of accuracy for the density. So the first thing we can say is, what's the formula for density? And density is given by mass divided by volume. So that's important because that will enable us to calculate what the density is. So we're given these measurements, but they're all rounded up. So we need to find what the upper and lower boundaries are for each one of these values. So for the length, we could imagine it's a number line like this, where we've got 13.2 is our recorded measurement. If we look at what the measurement below it would be, that would be 13.1, and the one above would be 13.3. And when it's rounded to 13.2, it means really that the true value lies anywhere in the range that's halfway between the 13.1 and 13.2 and halfway between the 13.2 and 13.3. So the true value lies anywhere in that range, where that value would be 13.15, which would be our lower bound, and that value would be 13.25, which would be our upper bound. So I could begin to create a table here. So we could say, well, for the length, we've got a recorded value, we've got an upper bound, and we've got a lower bound. So our recorded value, 13.2, our upper value, 13.25, and our lower value, 13.15. We're going to do the same for the width. So our recorded value was 16.0. So let's draw that number line again, 16.0, meaning the one below is 15.9, one above is 16.1. Taking the halfway points would mean that our lower bound there was 15.95, and our upper bound, halfway between the 16.0 and 16.1, will be 16.05. We'll do the same for the height. So we've got a number line, we've got our recorded value is 21.7. So here it is, 21.7. Our upper bound then, 21.8. Or not upper bound, the value just above 21.8. The value just below 21.6. And so these are our boundaries. Our lower bound here is 21.65. Our upper bound, 21.75. So having got those values, what we then need to do is calculate what the volume is. So we don't have a recorded volume because we're going to need to calculate it from these upper or lower boundaries. So the upper to get it, we'd multiply the length times width times height, because it is a cuboid. So the formula for a cuboid, length times width times height. So we'd multiply all these together to get what the upper value of the volume could be. So if we do that, we actually get 4625.409 with a few more places after that. And for the lower bound, we get 4540.925, again with a few places after that. We're also given the mass, which is not measured perfectly accurately. Again, that's rounded up to the nearest 5 degrees. So we've got the mass and recorded value, 1970. So we have to be careful on this one, because if we draw a number line, there's 1970. But this time we're going to the nearest 5 grams. So we're going to go down, the one below would be 1965 grams, and the one above would be 1975 grams, measuring to the nearest 5 grams. So that means that the boundaries have a minimum point here of 1967.5 and 1972.5. So there we go. So our upper boundary there is 1972.5 and our lower bound 1967.5. Okay, so what we need to do is work out from that what our minimum and maximum values for the density would be. So let's have a look. Our upper boundary for the density, so let's say upper density, would be equal to, looking at this fraction with a formula, the upper boundary would be when the mass is the upper value, so the top of the fraction is the biggest it can be, and the volume is the lower value, so lower volume. So if we do that, the upper boundary for the mass we got here is 1972.5, and our lower value for the volume is here. So the 4540.925. And if we do that on the calculator, what we get is 0.4332. And we could keep going with that. So 0.43328. If we do the lower boundary now for D, for the density, that would be given by taking the lower value of mass divided by the upper value of volume, because we make the top of the fraction as small as we can and the bottom of the fraction as big as we can. If we do that, then what we see is we take the 1967.5 over the upper volume. So the upper volume is this one, 4625.409. And if we do that, we get 0.4253. I'm continuing on. So what we need to do is we need to give our answer to a suitable degree of accuracy. So we've got an upper value at the moment of 0.43328, and we've got a lower value of 0.425. And our suitable degree of accuracy is the point to which the upper and lower value both agree with each other. So we can see that to one decimal place, what we would get is we'd get 0.4. And for this one, we get 0.4. So they agree. So we could say it's 0.4 to one decimal place, and both the lower and upper boundaries agree with each other. If we do it to 2 decimal places, we get 0.43 here. And if we do it to 2 decimal places here, we'd also get 0.43. So we can say to that degree of accuracy, the upper and lower boundaries agree with each other, and so that would be a suitable degree of accuracy as well. If we did it to a 3rd decimal place, we get 0.433 for the upper value, but if we did it for the lower boundary, we get 0.425. So we can see that actually they only agree up to the point of 0.43, and that is our suitable degree of accuracy, 2 decimal places, 0.43. So I hope that's been helpful to you. If it has, please like our video, and subscribe to our channel, which is bestmathstutors.co.uk. Thanks for watching.